Alright, today we are learning all about the albedo effect. Your notes are already posted on Canvas. If you are somebody who does them pencil paper, you're welcome to print them off, or if you have your notebook, you're welcome to do that too. If you are somebody who likes to do them electronically, your electronic editable copy is already up there. Again, today we are studying the albedo effect. It is the very last of our climate change lectures before we go into doing a small little project, a research project, and your test. So part of my question, or part of the reason that we're talking about this, is albedo effect has a lot to do with raising the temperatures of the Earth. It doesn't play a part, but greenhouse gas effect affects albedo a little bit, and we're going to see why. But again, this is something that has to do with climate change. You probably have never heard about it before, and that's okay. That's why we're learning about it. But in short, if you look at my definition right here, the albedo effect is a feedback loop between temperature and the amount of snow and ice. So we've got the loop over here on the side. So as ice melts, we have less radiation is reflected, meaning that temperatures increase. That, in short, is our albedo effect, our loop. And it's loop or cyclic because it continues again and again. So we call a positive feedback loop. And we're going to study a little bit more about what albedo is and look at the loop a little bit more. But the goal, or by the end of this lecture, you should be able to identify what kind of places, structures, whatever have you, might have a high albedo, and what might have a low albedo, and how those affect climate change and might change the temperatures of the Earth a little bit. So again, it's the two key players in the albedo effect loop are temperature and snow and ice. So albedo is a measure between 0 and 1 that corresponds to the percentage of radiation. Radiation, again, is the sun's energy, the rays that come in, that is reflected by the object. 0 is low, and a low albedo is not good. That means that almost all, or if it is 0 down here, that means that all of the radiation is absorbed. 1 is high, and that means that all of our radiation is reflected. And when we're talking about climate change, again, low is bad, and 1 is good. And if we've got a mixture of ones and zeros and all those kinds of things, it's good. But once we start having more lower numbers and less higher numbers, that's when we become unbalanced and our feedback loop comes and plays a part in what's going on. So again, albedo is the measure between 1 and 0 that corresponds to the percentage of radiation that is reflected. So 1 reflects 100% of the radiation. It goes back out into space. 0 absorbs all of the radiation, meaning that 0% of it is reflected into space. So we've got some common things here with our labeled albedos just to kind of give you a perspective, and you need to write these down on the side of your notes. There's an area for you to type it or write it, and if you want to draw yourself a little picture so you can remember, that would be good too, if you have the capabilities, or put a picture in on our documents here. So let's start low. So water has an albedo number of 0.08. That means that about, let me do the math real quick, only 8% of the radiation that is hitting the water is reflected back out into space. Only 8%. That means the remaining 92% is absorbed into the Earth and heats up the Earth. Forests are at 0.1 for an albedo number. That means that 10% of the radiation that hits the forest will reflect back out into space. The other 90% will be absorbed into the ground. Sand has an albedo number of 0.25. That means that 25% of the radiation that hits the sand will be reflected out into space, while 75% will be absorbed into the sand or into the earth. You can experience this on a hot day when the sand is so hot it burns the bottom of your feet. Clouds, now depending on the cloud color, range from an albedo number of 0.4 to 0.7, depending on the color of the cloud. If I have a darker color cloud, like right here, more of the light is going to be absorbed, more of the radiation is going to be absorbed. If I have a white colored cloud, more of the radiation is going to be reflected out back into space. And then lastly, we have snow and ice, which come in at an albedo number of 0.8. That means that 80% of the solar radiation that hits ice or snow is reflected back out into space, while only 20% is absorbed into the ground. Good. So now that you know that, let's test your knowledge a little bit. What do the albedo numbers mean? So again, clouds reflect about 40 to 70% of the sun's radiation. We learned that clouds have an albedo number of 4 and 7, meaning that they reflect about 40 to 70% of the solar radiation. Same with the snow. We learned that snow has an albedo number of 8, meaning that it reflects about 80% of the sun's radiation back out into space. Forests, on the other hand, reflect about 10% of the sun's radiation. The remaining 90% is absorbed into the ground or into the trees, or whatever it is that it's hitting. And then water reflects about 89, although we learned that that math was a little wrong. It reflects about 92% of the sun's radiation. Or, excuse me, that is completely wrong. Water does not reflect 82%, it absorbs 82%. It reflects about 8. This should be just 8% of the sun's radiation. Fantastic. So, knowing what you know now, if I have a surface, say a parking lot, that has an albedo number of 0.03, how much radiation is reflected? So based on that albedo number, you could tell me, or you should be able to tell me, that about 3% of the solar radiation is reflected. That means that the remaining 97% of that radiation is absorbed into the ground. Where did the other percent go? That 97% of the radiation that hit the parking lot surface is absorbed into the ground. Now, why do we care about albedo number, and how does this relate back to the albedo feedback loop? If you look right here, we have the albedo feedback loop, and we see that warmer temperatures lead to less snow and ice. That's what we learned. What happens when it gets warm? Our snowman melts, so we have less snow and ice. And then less snow and ice, we learned, leads to more sunlight being absorbed by the land and sea. So if you can imagine, if I had a continent, perhaps, that was completely covered in snow and ice, that would be great, and that would reflect the solar radiation back out into space, making it not as warm on the Earth. But if my temperatures have raised, some of that snow and ice is going to melt, making the below surface, which is typically like green or brown, which has a lower albedo, meaning that it reflects less out into space. That absorption of the sun's energy by the land and sea, because it's no longer snow and ice, is going to make temperatures even warmer, because we learned that the land and the sea absorb more sunlight, making it warmer. And then because the temperatures are warmer, even more snow and ice melts, and the cycle is repeated. And if you're not careful, or if you start thinking about this too much, you might feel that it's kind of an endless cycle. And I mean, it is. It's a cycle, and it makes it worse. That's why it's called a positive feedback loop. So the effects of it are made even worse and worse. But there are things that you can do to help mitigate or lessen the effects of this feedback loop. For example, let's say I have a home and I'm building it, and I want to design a roof, and I'm environmentally aware, and I am a good environmental citizen, so I want to put on a roof that has a high albedo effect. That way, we help decrease the effect of this feedback loop right here. So if I wanted a surface that had a high albedo, generally it would be white or light colored. So if you did notice back here, the darker our substance is, typically the lower the albedo, meaning that it's raising temperatures. The lighter the substance, the higher the albedo, meaning that it is reflecting more out into space. So I want my roof to be light colored or even white so that the light or solar radiation is reflected. Now, not only does this make you a better environmental citizen and more conscious of your effect on the earth, it's also going to help your AC. So if you read this little comment right here, since I live in a hot area, because you live in North Carolina, maybe your AC doesn't run all year long, but let's say maybe we move to like Florida or something, and my AC runs all year long, my roof should have a high albedo effect. The more radiation the roof reflects, the less energy I will need to cool my house. Because if you have a dark colored roof, you aren't reflecting as much of that solar radiation, you are absorbing a lot of it, which will make your house warmer. So not only from an environmental standpoint do we want to be very conscious of what our roof is looking like, but this could also save us money in the long run. And if you think, again, with an environmental mindset, the less my AC has to run, the more energy I'm saving, which again is better for the earth and the environment as well. This also comes to play when we think, and sorry for the quality of this picture, but when we think about town planning. So what kinds of colors am I painting my buildings? What kinds of roof am I putting on my buildings? Do I have a lot of green space? Do I have a lot of dark colored pavement? So you can start maybe planning a city if that's the career choice that you're going for, or perhaps just being an involved citizen who has an environmental standpoint. Like if you look right here, white paint or a white painted building has an albedo of from 5 to 9, which means a lot of that radiation is reflected back out and not absorbed, while colored paint has a much lower albedo at 0.15 or 0.35, meaning that a lot of the solar radiation is actually absorbed into the building. Same with our roof types here. If we have a highly reflected roof, like my white roof, I might have an albedo of 0.6 to 0.7, or if we have a typical roof or like a brown-red roof, we have much lower albedos, meaning that a lot of that energy is being absorbed. One of the recent things that they did here in E-Town was create a new fire station. The new fire station was a brick building, and then they decided to paint it white. It was more for an aesthetic reason, the decision, but I do have a friend who is a firefighter who was completely upset because his fire station wasn't red like a traditional one, but it was white. And I was able to have a conversation with him about how the white paint allows the solar radiation to be reflected back out into the atmosphere, and it was actually a better decision from an environmental standpoint. And that really didn't change his mind, but it was a conversation that I was able to have because of this. The last thing I have is linked on your page. It's a video about from NASA that's talking about the albedo effect, but also it really ties together what we've been learning in a succinct way, talking about climate change and the albedo effect as well. So give that a look. It'll be very helpful for you. Have a great day, guys.